So we'll finish the final exam review. And I'm going to annotate. So this is after graphing. You will, on the final exam, have to deal with the radicals. So we've just done this recently, so it's fresh in your mind. But really, if you're simplifying a radical, what your goal is, and these you can do different ways because you can use, you know, I'm going to show one, but this isn't the way I'm going to do it. Some of you like this, the nth root of a to the m is a to the m over n. You see some people do that and get rid of the radical that way, and they say, oh, okay, so this is, the index is always my denominator. So this turns into an x cubed, you see? That's one way to do it. But then it doesn't work as well for the 64. So it works really well if everything is exactly evenly divisible. So for that y to the 12th, it also works well. But what if you have one, you know, where you have the cube root of x to the 8th, you know, then what do? This doesn't work. So I like the way that works for everything. So I'm going to try really hard to write everything with an exponent that is evenly divisible by the index. So, or that matches the index or is evenly divisible, excuse me. So we have a -4 cubed because 4 times 4 is 16 times 4 is 64. Or you can use your calculator, and negative times negative times negative is positive, is negative. Negative times negative is positive times negative is negative. So, you know, this here turns into that. In this specific case, you don't need a parentheses, but I always like to encourage them because you need them when it's the even numbers. Then we have an x to the 9th. It's already evenly divisible by the index. So if this were an x to the 10th, I would put a step in and say I need something evenly divisible by the index, and then I'll see what's left over. But in this case, it's evenly divisible. So you could just write it as, my goal is to make that a 3. You know, that's the goal. So you want to focus on what's your goal. So my goal is that to be a 3. Well, if I have x to the 9th, I have no choice but to put an x cubed inside. See? 3 times 3 is 9. And then you have the goal of a 3. I add them. And then we have a y to the 4th because 4 times 3 is 12. And then you say, okay, the nth root of a to the n, that's whatever that a is a, meaning if this is the same thing as you saying n over n is a to the 1st, which is also that. You know, or you can just memorize the nth root of a to the n is a, meaning if the index matches the exponent, that a comes out. Radical's gone. So what do? You say, oh, that thing has an exponent of 3. This is a little dangerous here because you see 2 3s, but you just want to say, oh, this piece has that exponent, so this piece comes out. Happens to have a 3 with it. This piece has that exponent outside of that parentheses. That is a 3, so that comes out. And this is the end of the story. I like the ones better that also have something left over underneath. But it's spring 2020. You know? So I can't guarantee later we're going to have some where we add and subtract, and you'll have to deal with that probably, if I remember right. Check quick chats. Okay, yes. It is a beautiful morning. And right after this, we all head outside.
Yep.
We were catching, well, I was trying to catch frogs. He did catch a frog yesterday.
Wow.
That made him very happy, but I let it go after a while because I do not want him breaking legs and stuff. He's 3. So I told him now to thank the frog for playing with you and then let it go and say bye-bye. And then we caught some tadpoles and put them in a big old bucket with water and some minnow fishies, you know, with a net out of the pond. And when you scoop into the mud, you get some good stuff out. And then he entertained himself while I put fence up. It was fun. So anyways, nothing math related, but you know, math isn't always fun. Right. Find the power of I. So the power of I to the 4th is my golden child 1. Yes?
Mhm.
So if I can make something into I to the fourth, I can simplify it really easily. And then I look at what's left over. So this is the square root of -1 is I. I squared is the -1. I cubed is I squared times I, which is a -I. And then I to the fourth is that one. And so you really just need to memorize these two. And then we go from there. So here, but when they get bigger, I need to split it into an exponent evenly divisible by 4. And I always like to show this going back to all the way to the details, but really you can just memorize that if it's evenly divisible by 4, it automatically turns into a 1. So we're going to take this thing and split it into I to the 40th times I, which if you multiply them, the 40 plus the 1 technically is the 41. This turns into a 1. I'm going to show that again off to the side because I want you to really understand it. And 1 times I is simply I.
Mhm.
So if you want to, you can show the I to the 40th because your goal is to get an I to the 4th here. There's a 10 here. 4 times 10 is 40. And then you could say I to the 4th is the 1. 1 to the 10th is 1. You see, and 1 times I is still I.
Mhm.
So, and then I like to show one more. I don't know. I never come up with good examples. I to the 38th, let's say. Not evenly divisible by 4. What's the closest one? I to the 36.
Mhm.
I to the 36, if that exponent's evenly divisible by 4, you immediately turn it into 1. And 1 times I squared is I squared, but I squared is not an option. So in this case, it's the -1 because I squared is -1. How are we doing? This is good. We can move on. So you have your 4 options. Your answers are going to be any one of those. But the thing is, you either get it right or wrong. So there's 2 points or 0 points. You don't want to mess around with this and not understand it. Okay. And I'm happy to go into greater detail if you want. Right in terms of I. Okay. So first of all, I would just say simplify, really honestly. But this is a 5 in the front. Square root of -1 is I. So I'm going to say, let's pull the I out. And then we still have a square root of 18. And we want to simplify it still if we can. And 18, 2 times 9, 9 is 3 squared. So we can write it as 2 times 3 squared. The 3 comes out. And then people struggle. Do I multiply that? What do I do? And I'm like, yes, 5 times 3 is 15. And the computer will let you do 15 square root of 2i. But folks, I've seen some sloppy work on discussions and stuff. That I needs to clearly not be under that radical.
Mm-hmm.
So that's why I like to put it in front of the radical. Then I don't have an issue if I'm being sloppy. Cake, so comfortable. So today should be going pretty fast, and then I'm here for questions on other things, specifics, etc. Add and subtract. This is where it gets a little bit more complicated or in depth. So, and I don't know, I don't think we did this one specifically for the exam review. This is the final review here, see, and we did the other day, we did the exam review for exam 3. So to add or subtract, you need like terms, and like terms in this case means same radicand thing under the root and same index. So that's not true for any of these right now. This is an apple, an orange, and a banana. But if we simplify them, maybe stuff will happen, So 9 is 3 squared, A. And now we have to use those skills with those, evenly divisible So b to the 11th, I need it evenly divisible by 2. I could split it into b to the 10th times b, true? So I'm going to split this up, because this is a radical. Then I could say, well, I need an exponent of 2, so I could split this into, I need a 2 here. So I can do a 5 here. 5 times 2 is 10, and I still have that b hanging there. You see, that's what we're doing. So I'm going directly, because we're going to run out of room, but we're going to go directly to that. So that's that first piece. And then check your work. 5 times 2 is 10. 10 and 1 is 11. True. Then we have minus. 25 is a 5 squared. A to the 9th can be split into a to the 8th. But I need a 2 here, so that needs to be a 4 times a. Do you see it? So some of this will take you a little longer, and that's not a problem. But 4 times 2 is 8, plus 1 is 9. B to the 11th, so that again. So these are all, you could have gone ahead and said, I'm going to simplify them all the same, but I'm trying to be consistent. Sometimes these will be like terms. In this case, they're not, because this has that 25 and this has that 36. So sometimes they're actually like terms, and you can combine them first and then simplify each one. So I don't always notice that, and sometimes I'm doing extra work here. It all depends on how you look at it. A 4 times 2 is 8, and that a hanging there, and then we still have that b's again. And then I run out of room. So then I simplify. So the 3 comes out. The a does not come out. The a to the 4th is here existing. The b to the 5th comes out. And then I say what stays under. I have that a under and that b under. Yes? Then I have a minus. The 5 comes out. The a to the 4th comes out. The b to the 5th comes out. And then the a, b stays under, and that gives me a clue. Now sometimes it's tricky, be careful. 2 of them will combine and the third one won't work. So just pay attention, don't just assume that they'll all be like terms. The 6 comes out, the a to the 4th comes out, the b to the 5th comes out, and I know it's like, oh, this is so repetitive. Yes, math takes patience, a and b, and so do the little kids, right?
Right.
Okay. They're so fun though, but sometimes I find myself yelling, and then I'm like, oh my gosh. So because while I wasn't watching, he dumped the water out of the tadpole thing. I'm like, you're killing the tadpoles. We have to save them. And he's just dancing around oblivious, I'm like, we got to get these tadpoles back in the water. We saved them all but one, I think. Because if I counted, I had like 17 fishies and like 4 tadpoles. And I think I only saw 3 tadpoles go in the water. I'm like, that is not our intent. Our job is to play with them and gently put them back and never harm.
Right.
But it's a struggle with little kids, but I'm trying to teach him empathy early, because that's a good thing nowadays, especially. Yeah, you don't want some bully. Okay, so 3 apples, or let's make it dollars because it's hard to go into the negative 2 apples. $3 minus $5 plus $6. So 3 minus 5 is a negative 2, plus a 6 is a 4. Is this right?
Yes.
Okay, thank you. So, yeah. I just want to talk about other stuff other than math, I guess. I'm so distracted lately.
It's been a long semester, hasn't it?
It's been a little bit rough, yeah. And there's so many students that are working so hard, and I'm so happy to help. And then I have those that are just completely ignoring everything. It's just frustrating. Because you try to help people, and or they think they can get away with it, and they will maybe this semester because of COVID, but it's going to catch up. So you guys are doing the right thing. Okay, multiply. So if I have a binomial squared, I have to use that formula. Or I can always FOIL, yes? The one thing you're not gonna do is just square this thing and square that thing because there's a plus. So if this were multiplication, then yes, but this is a plus. So you have to be careful, either use this or FOIL. Most of you will FOIL. And that is completely okay. FOIL first, and I'm showing every detail, outer. Be careful here that that x is not under the radical. X squared of 5 is 5 squared of square root of 5x, you see, because the commutative property. So we're going to go ahead and call it that. And then x times x is x squared. Then you have a 5 come out. You have square root of 5x. Now this is dangerous because you're adding. This is adding. So this is like me, okay, so should we write them as x squared of 5 plus x squared of 5? Is that better? Then you have 1x squared of 5 plus 1x squared of 5 makes 2x squared of 5. Do you see what I'm saying? So this is a little bit dangerous. If you can put the square root in the middle, I just don't want you to extend it over the x. The computer will take it. And then people say, well, don't I need to put it in order? You know, usually we're used to order from greatest exponent to least. I do believe it'll just take this. It should take this fine, or you can write it as this. So, question? So the same thing would happen if you had said, I'm going to use the formula. This is A. Square root of 5, you know, if you square that, you get a 5 out. 2 times A times B, because this is A, this is B. So you still get 2x square root of 5, because you're just multiplying 2 times this times that. And then plus x squared. You see what I'm saying? That's if you like formulas. So. Now we're going to solve, because it says solve, so we better solve. Did you hear that? Okay, so if you're solving a radical equation, you need to first isolate the radical. In this case, it's a gift. You already have it isolated, yes? So if this had a +2 hanging there, you'd have to get rid of that 2 and move it over. But this is already a radical equals something. And then you use this is not where you use the square root property. This is where you use the power rule. You see, so if it starts out radical, you're going to get rid of that radical by doing whatever. If this is a cubed root, then you would cube it to bring this stuff out. So in this case, it's a square root, so you would square this to bring that out. Whatever you do here, though, you have to do here, yes? So then you bring out the 35 minus 7x, and then you watch this thing. This is a binomial squared again. So it's the x squared minus 2 times a times b. This time there's no radicals, so you can put the 2 and the 5 together. Plus 25. Or you can do x minus 5, x minus 5, x squared minus 5x minus 5x. I know I show that 100 times a semester, but it's just so important. And then you borrow 5, you borrow 5, you owe 10. Yes? So whatever you do, it doesn't matter which method. And then, now you solve. In this case, it's quadratic, so maybe you should bring everything over. Now, how about we don't bring this to the left and make a mess? How about we bring this 7x over, and we bring this over? And this looks so very familiar because we just did one when we prepped for this last test. Negative 10 plus 7, 25 minus 35. And then back then I said, hey, back when we did those radicals, we didn't know how to do chapter 11. So we didn't know how to complete the square. And we also didn't know how to do the quadratic formula. So actually this immediately, when I start with an x squared, I immediately want to take the easy route and say, can I factor it? Because it's the quickest. If you do this quadratic formula, a is 1, b is -3, c is -10, oh my gosh, it's going to take you forever. And you could have just done this, right?
Mm-hmm.
My product is -10, my sum is -3, -5 plus 2, -5 times 2 is -10, -5 plus 2 is -3. Then we say, if a times b equals 0, then a is 0, or b is 0. X is 5, or x is -2. And then we have to check, because this is the mandatory. You should always check. We don't always take the time to do it, but mandatory if it starts radical. Yes? Because we might get an extraneous root. So yeah, I'm just reading the chat now. I decided I wanted a break in the middle of this problem. Won't you check them? Thanks, Adam. Yes. Wow. So, and then the question is, do they still take the same final? You know, I'm reading Adam's chat here. I have some cake still. It's my husband's leftover hazelnut cake from his birthday, a German recipe from imported German hazelnuts that I actually haul over here.
Wow.
Sometimes I want to fly home just to get my hazelnuts. And when the Germans come, I'm like, you better haul me some over. So my brother gets stopped in the airport and he's got all this vanilla sugar, which looks suspiciously like, you know, I don't know, cocaine or something. And, you know, he's, yeah, he looks very severe, single male, you know, and they immediately like strip search and stuff.
All for your sugar.
So I guess I better check this now. See, I'm so distracted. I just want to have fun. And we're having fun. This is fun for me when laughing with you guys and goofing around a little bit. So remember, you're checking it in the original. I just miss that fun in the classroom because we've always had a lot of fun in the class. And it's really hard to do that online. So Amber, I'm so glad you're coming to these because
No, I wish I would have taken the on-ground class from the get-go. Now
yeah.
I
know. Some people like to be very serious and they think they need to be so serious.
Life's too short.
And you know what? I just don't care anymore. And then I'm like, well, I'm older, so I don't care anymore. But they're old and they do care. Maybe they're just burned out. I don't know. 35 negative times negative. This is a good thing about starting career late is you don't get burned out so fast. You know, like I haven't done this for 25 or 35 years. I've only done this for 10, 12 years, you know, full time for 8 years. So I have a little more energy still. I don't know what I'll be like in 10 years. 7 equals -7, never, right? So this is that one you have to throw in the trash. But don't always throw the negative in the trash.
Right.
Just sometimes. The final answer is X is 5. I don't know if I should record this. I mean, it's being recorded already, so it is what it is. I'm really not sharing this with colleagues.
Well, if you do, at least they'll know we love you.
Yeah, thank you. But then they're like, oh, she calls us boring. I've just observed a lot of classes, and some of them are really fun, actually. We have some fun colleagues. They're goofy too. But some people really take themselves seriously. Now, I've taken a lot of classes, and there was one instructor who really made life fun, and she made me love this because I hated math, and so that was elementary algebra back in the day, 1999 or something, and she was awesome. So she changed my life. So I feel like, oh, if I can do that for one person,
Right.
then I've done something positive in my life. So anyway, okay, use the square root property. So we're not immediately going to take the square root of both sides. We're going to say if x squared equals k, if something squared is constant, then that something is plus or minus the square root of k. So for you to do this, you need to first isolate the x squared. You see it? Yes? Subtract 54, then divide by 3. And x squared equals negative, help. You guys, 18? No. Thank you. And then x is plus or minus square root of negative 18. Yes? And then you pull the I out and square root of 18. Excuse me, square root of 9 times 2. So the 3 comes out. I'm going to squeeze it in there. Yes? So this is just imaginary, really. All is well?
Mm-hmm.
Okay. I'm just checking because I wasn't sure. If you look confused, then I'm doing something wrong, usually. So now we're going to complete a square. It never hurts to do that again. So critical for the next class. So this tells you the equation has real number solutions. Who cares? So this is just telling you if you pull an I out, you got a problem, but it really shouldn't tell you that anyway. I mean, this is like the stuff I don't like online. So step 1, if I'm completing the square, I need, this is my goal, right? I need, and this thing has to be a 1. In this case, already there, so that's kind of a gift. So I need to move over that 74. And then I do my little blanks. And if you go back to the discussions, the people that use the blanks are the ones that followed the directions, either watch the videos or were here in Zoom. Then there's people who didn't use the blanks, but they did everything right. And I kind of know them, so I know that they didn't just Google an answer, But some people ended up with weird answers with elements, symbols like this. And I actually told them, you're using a symbol like this that we've never used tells me that you're using something other than,
Right.
you're not doing what you're supposed to be doing, and it'll catch up at some point. Like we had some of them that, not in this case, but they ended up with a square root of a negative, and then it's you guys know how to simplify them. You've been trained to simplify them. And they said, oh, X is not element of real. This is not a notation you know how to use. This isn't, anyway, this just means X is not a real number. But you guys know how to simplify imaginary numbers, so I'm like, you're just really telling me that you're cheating right now. Arg. Okay, so I transgress. transgress, is that the word? I just don't care anymore, you know?
Yeah.
I just don't. I care about you guys, but I just don't care anymore how appropriate I am or how serious. B is 18, yes. What is 18 half? 9. What is 9 squared? 81. This is the outside goes outside. And this is the inside, and that's what goes inside that binomial. Watch that sign, because if that's a negative, be careful, you know, but it is a positive. And then, did I do something wrong? I feel like I did something wrong, but I see Ch10.
No.
Oh, thank you. You guys are awesome. Make me want to keep coming to class. That's right. That's what makes the class fun. Okay, so then we do the square root property. So interesting, this one. And you know, this is why it said real number solution. It tells me right now, and I can see it coming. And then you have to decide, when do you want to split this stuff up? When do you want to split this up? I'm looking for my eraser, can't find my eraser. Yes. So now you can split it up, or you could have moved that 9 over first, but then people get confused. But this really means that x plus 9 is 9, or x plus 9 is negative 9. Yes? And then you isolate. So x is 0, or x is negative 18. Yes, Amber, what did I do wrong?
Well, no, I'm just curious. Did the negative 74 plus the positive 81?
Oh, yeah. See, you guys, could you have said that like 20 minutes ago?
Sorry. I always think it's my bad, so I hesitate to say anything.
No, it's me. Right after you guys say I'm great, I butcher it.
No, you still up.
But I would have caught it because I would have checked my work. But yeah, arg. I brought that 81 over. See, this is what happens when you try to talk, and I'm blonde too, you know, so chewing gum and talking at the same time or thinking, it just doesn't work. Okay, 81 and 74. 7?
Yeah.
7.
Okay, thank you. So there, I really don't want to share this now. Positive 7, yes?
Yeah.
That's not 7. That's 7. Yes? Maybe I should have just called this good. Okay, said, hey, use the old reviews from chapter 11. That was so recent. X equals negative 9 plus or minus square root of 7. That's even better. Now we don't even have to think about it. Is that what you got?
Yes.
I'm just trying to keep it real. I just want you to feel good about when you make mistakes, just laugh about them and move on. The quitting is what's the problem. If you make mistakes and you quit, then you have a problem. If you make mistakes and you laugh at yourself and you keep going, then it doesn't matter. I know. And you know, I want to so bad teach the 114 because I have so many students I want to follow. The problem is I do a lot of good work at the 110 level and 112 level. And the 110 suck up a lot of my hours because they're 5 credit hours. I'm only allowed to teach so many hours, you know? So I'm limited on, and I'd hate to give up a 110 where I can help a lot of people maybe like math.
Right.
Yep.
You know, it's a struggle, but I want to, I'm trying to debate on how to pull it off. And then I've started teaching the German, and that sucks up more hours, which it doesn't affect my full-time load, but it does affect my overload, which I always teach overload. My full-time load has to be math because I'm a math instructor. So anyway, it's a struggle. Yes, I want to really bad.
But this is where you're needed.
I feel like I do the most good here, you know?
Yep.
although the material gets pretty old after a while, but if I can help more people hang in there, and then once they're through this, they usually hang in there for the 114. And there's lots of good instructors. So just, yeah, work hard and ask questions and demand help. That's what I like about that Fear of Math video where she says, ask for help, demand help. So quadratic formula, you need first standard form. Whoops. Yes? So do not plug in A is 3, B is -2, blah, blah, blah. So, and then we say A is 3, B is -2, and C is -10. And I truly feel like the people that are here right now don't need this. You've done this before. You were good at it before. You can do this again. You know, you did it just now on the exam, and I'm still reviewing exams if you ask me. You know, but the folks that would really benefit from this stuff are not a lot of time. They're completely ignoring it. They're also not watching my videos. So anyway, where x equals -b, yes, plus or minus the square root of b squared minus 4ac. So very carefully, I'm checking my work again because I've already messed up today. I do it every day. That's okay. I just don't want to do it twice in one session. All over 2a. Catch me if I'm wrong, please let me know before I get done with this thing. Negative times negative is positive. -4 times 3 is -12. -12 times -10 is positive. This is a good one maybe for some of the discussions we're having of where to stop, how to split them, what do we do? How are we doing so far? Okay. Nice and slow. Now the 124, I want to split it up. I can kind of see what's going to happen. 62. Is that right? I'm actually kind of glad. I was afraid it was going to be a 64, and those are 2 to the 6th power, and then we get, yeah, this is better. Is this right? 124,
Yes.
okay. So I can write it as a square root of 2 squared times 31. I'm showing every single step, you know, all over 6. The 2 comes out. Then you have that option. You say, okay, if I had an I with this, I would definitely split them and then simplify, you know, because you need a real term and an imaginary term. But this doesn't have an I, so you don't split them unless you want to, but you still have to simplify. And you see how there's a 2 in here, a 2 in here, and 2 in here. So you can either do that triangle thing. I don't usually advise it. So I'm going to show it both ways. You can split if you like chapter 5. Oh my word. The ants are doing something in Buck's life. I have no idea. Square root of 31 over 2 over 6 is 3. And then since it's not imaginary, I would probably put them back together. I squeezed it. So Amanda, is this helping at all, or because I know that sometimes this is a little bit rough.
Yeah. Yes, it's helping.
Okay, so and then I'm going to ask, like, you know, Brandy likes the factoring, and I like the factoring too. Sometimes the factoring still makes me have to work harder and do something else, but let's look at that. if you like factoring and you would say, hey, the top, they have something in common. They both have a 2. 2 times 1 is 2, and 2 times square root of 31 is 2 square root of 31. See? All over 6. Now, it's all multiplication, you know. Factor, factor, cancel, cancel. You see how you're still going to get the same exact answer as if you split them.
I think I was missing a couple steps, which is why I was getting some of it wrong.
Okay. And then I had another student who did a great job all the way to the end. And then she put the plus or minus in between the 2 and the 31, for example. You know what I mean? And then the whole thing was toast, you know? So you got to be careful where everything is. Yeah, my kid has a lot of fun. He screams a lot too, though. I'm not his best friend all the time.
Then that means you're doing a good job.
Yeah, you know, you're not my best friend, and I'm not helping you anymore. And he's crying too at times, I tell you. I'm just the worst when I turn that TV on. No, I really, balance is important. He can only watch so much TV a day. Anyway, so how are we doing? Amanda left us. I think she got kicked out again. She's having some internet issues at times. That can be really frustrating, you know, when you're trying to work hard and then the internet keeps interrupting you. So this is the end of that. So do we feel like we're okay for, I mean, how do we feel about the final? You know, that's the question. And then you can say, well, that's a lot of material. It's a little intimidating or overwhelming. But then I want you to think back, hey, when we started looking at graphing again the other day, how everything came back to you. You know, and you have to trust that when you open that final, you're like, oh, this looks familiar. Oh, I'm dealing with a, you know, graph right now, and this is what I need to do. So anyway. And you're allowed to use your notes, you know, there's nothing I can do. I wish, some people do worse with notes because they get so, you know, you have a time frame and then they get caught up in notes and they get hung up.
You say we were allowed to use notes?
Well, I can't watch you, can I?
Well, I mean, but if you're not supposed to.
I'm asking you not to.
Yeah.
I'm telling you that the reality is, you know, what am I going to do about it?
Yeah.
You know, so but I do think that it hurts a lot of students because they look at their notes and then you get lost in your notes and then you confuse yourself more, and you would have been better off just focusing and saying, oh, this is, what do I do? Oh, maybe I should plug stuff in, or, you know, do, you know, what do I do first? And think about all the steps.
I did have a question about that last question, like when to check your work with the original and when not to. So like
yes.
that last one, you really can't check things like that, can you?
You can.
Because they just don't, I try to check my answers with all those square roots.
You totally can, because when you're squaring this thing, stuff is going to happen. And it will work. It's just convoluted. It takes time. So I'm happy to do one of those, but I would turn the recording off first because I don't want, you know. But so the one where, when I did it wrong, you know, so I messed up here and I forgot that 74. And then I had a 0 and a 9 as an answer. I would have certainly checked them, and guess what? I would have been so wrong, because 0 squared plus 18 times 0 is 0, so 74 equals 0. That's garbage, you know, so I know that's wrong. So then I would have caught my mistake. But yes.
So if we feel comfortable with the review that we just went over, do you think we're probably good to go to take it in the morning?
I think if you feel comfortable with this, with everything that we've done this week, then you're ready to go. And you can get it over with. So last night, again, I'm gonna stop the recording, hang on.